So I got to thinking, what are you made of? And fundamentally, you're made of stuff. Uh, what kind of stuff? And so, well, we've been talking about that thing. We've got some stuff that resists acceleration. It doesn't want to change its state of motion. So we've also got some stuff that exerts the gravitational force. I'm working on my handwriting some more. Gravitational force. And we have a name for this stuff. It's called mass. If I can work the marker. This is what mass is. Mass resists acceleration. This is Newton's second law. We've got, turns out, mass also exerts the gravitational force. So what about any other kinds of stuff that you have? Gravitation attracts. What other kind of stuff could you do? Could you have something that, say, would repel? So here I have a little plastic petri dish that I've taped together because I don't know what to do with petri dishes, and I've put in some candy sprinkles. You can kind of see them jumbling around there. They're nothing too exciting, just kind of there at the bottom. So now I'm going to rub it on this Russian hat that I have. So let's see here. Let's just, all right. And nothing seems too exciting, except now something has happened. They're not moving around like they normally would. Something's put something on it, did something there, but now I can get them to move away from my fingers. I can get them to do different things. Now I've got a repulsion. Let's leave this there, hopefully. Did it stick? No. Oh well. So we call this the electrical force. Or we're going to call this other stuff, well, that can attract, we've got, at least you can see that it repels. We're going to call this stuff charge. I just made it up. What is mass? Well, that's what the Higgs boson's for in the Higgs field. What's charge? Well, that's something else. We don't know what it is. But we have some properties on things that it can do. So what we have is this concept of charge. And make sure I remember everything. And we can... Mass's symbol is M. We're going to give charge another symbol. We're going to give it the symbol Q. Now, how much? Just like mass comes in little chunks, charge comes in little chunks. So a chunk of charge is 1 coulomb. It's an amount of charge. What's interesting is that charge also comes in smaller chunks. It comes in chunks of the electron. And an electron has 1 point, oh shoot, what was it? Crap, where'd it go? Oh, there it is. 1.60 times 10 to the minus 19th coulombs. So we can figure out how much charge is on it by looking at the number, this is number, the number of electrons that are in it. All right, where'd it go? So now let's talk about, this one's not going as well as I had hoped. It's Friday and I'm losing it. So let's talk about the fundamental theorem of electrical phenomenon. There's only one type of mass, and mass only attracts. However, there are 2 types of charge. There's the charge that's on the electron, and then there's the opposite of the electron, which is what is in the proton, and we'll talk about this. The electron has what's called negative charge, and the proton has what's positive charge. positive charge. So the fundamental theorem of electrical phenomenon is that we have negative and positive. Ooh, fat end. All right. Like charges repel. Opposite charges attract. So there you go. This is actually pretty simple, but it's not easy. We're going to come back to this quite a bit to tell you what's going on. But now they attract, but with how much force? Nice. That's where we get Coulomb's law. Now, Coulomb's law, this should be a little proud comma there. Coulomb's law tells you the force between charges. Or this is the electrical force. My handwriting is getting worse. The force between electrical charges. Well, it should depend on charge number 1 times charge number 2. So more charge you have, the more force you have. It turns out it's inversely related to the distance between those charges. So if you have charge 1 over here, here's Q1, and they're separated by some distance r, and here's Q2. Here's, I'll put a little shading on it. 2 charges. Here's r. It goes by the distance between them squared. Wow, this is looking very familiar. However, it's not directly proportional. You've got some constant out here on the front. This is called the electrical constant. Electrical constant. How big are these things? Look, it looks exactly like gravitation, and this is where you get this idea of that maybe electrical force and gravitational force are related. We're not going to talk about that right now. Here's your charge, here's your distance. Now, how big is this constant? This constant is 8.99, feel free to round it to 9, times 10 to the 9th. Newtons, meters squared, Coulomb squared, and that's just the constant to make it turn out right.